All right. Well, welcome everybody. We're excited to have you here on this Thursday morning for our 9:05 class. We'll be talking today about extraterrestrials, and in a moment I'll turn things over to Mark Breen, who will be teaching. My name is Drew Bush, and I'm the Director of Programs at the Fairbanks Museum and Planetarium. And I just, of course, wanted to welcome you all today and let you know that you can find all of our online offerings at fairbanksmuseum.org. For those of you joining us in Zoom today, I just want to point out a few small things. At the bottom of your screen, you'll see a Q&A button, and you can ask us questions in there. They can be answered by us. We'll try to do our best anyway, to answer them either verbally during the session, or we might also type you an answer. You can, of course, ask them anonymously in that box as well. The other place you can reach us is by hitting the chat button at the bottom of your screen. And on there, you'll see I've already placed a chat welcoming message for you, but feel free to chat with us in there if you might want to as well. For those of you on YouTube live stream or who might be watching this later on Kingdom Access Television or your other local cable affiliate, feel free to email us your questions either before, during, or after class, and we'll definitely tackle answering them at our next class or whenever we can. And you can email us at dbush@fairbanksmuseum.org. That's my email address. It's dbush, BUSH, @fairbanksmuseum.org. One quick note, we of course are recording this class for those who might view it later, so be aware of that if you do and choose to interact with us during today's class. And without further ado, I'll turn things over to Mark Breen.
Okay, well, thanks, Drew. So we're going to talk about extraterrestrials today, and that, of course, probably suggests a few things, just in terms of, an extraterrestrial. You may have a specific idea about what extraterrestrials are. So with that in mind, let's just kind of think about that. And so as we take a look at this, obviously one of my silly pictures here, but the idea is that, if we're going to be thinking about extraterrestrials, we need to think about what exactly is life and what does life look like. That sounds like an easy thing, but maybe not. So first of all, what is the extra in extraterrestrial? I mean, that's certainly a worthy question. We hear about them. We probably have a pretty, specific notion about what that is. And yet, what is extra? Well, it's extra in meaning beyond the Earth. So anything that's alive that's not on the Earth would be an extraterrestrial. So that could be anything from some kind of microbe or some kind of bacteria up to some sort of creature, maybe even some sort of human type of life form. Haven't found one yet, but those are all possibilities. And then in terms of terrestrial, I don't know if you ever gave that any thought in terms of, exactly what is terrestrial. If you're familiar, with the idea of the Earth sometimes being called Terra, there's your clue right there. Terrestrial means the Earth. So extraterrestrials, something that lives beyond the Earth, like this, of course. All right, so maybe that isn't exactly an extraterrestrial. If you're a cartoon fan, especially if you've seen some of the older cartoons, maybe you remember this guy. Now, here's a different idea in terms of an extraterrestrial, in which it's not from some kind of cartoon. It's really somebody imagining how a life form might develop in some other environment besides the Earth. So these are all ideas that you can play around with. But if we're going to be thinking about extraterrestrials here, this morning, then we've got to think a little bit about the two things that we're dealing with. One, we have to think about what something alive would need to live, and then exactly how do we know it's alive? There are things that move that aren't necessarily alive, or there are things that are alive that don't necessarily move. So how do we figure that out? So one of the first things that I'll pose to you, we'll think about what exactly does life need, So all living things have 4 requirements. Now, I'm going to give you a minute you can actually maybe type in some thoughts if you have in the chat box or in the Q&A. But so there's the idea. Can you think of 4 specific things that all living things require? Now, here on the Earth, it's the only place that we know specifically that has life. So that's kind of your guideline there. If you've got some, if you're anything that's alive on the Earth needs basically these 4 things. So as you're thinking about that, probably I would hope that one of the first things that you'll think about is water. We'll talk about why water is required in a moment, but right now, there's one thing that's kind of a key ingredient. All living things, as far as we know, need water in order to survive. The next thing is you need a place to survive. Now, that in some ways is pretty logical, but in this particular case, what we're talking about is specific conditions, a certain set of conditions. It may be hard, rocky places, soft, wet places, dry, warm, cold, these different requirements. So your living space has certain, characteristics to it. All living things in some form or another take in energy. We'll call that food. Now, there are various ways of doing that, and there are mostly because there are various types of species around the globe, but all living things need some sort of food. And the 4th thing, some kind of way to establish stable internal conditions. In other words, you need to basically kind of hold things steady. Now, if you think about yourself, what's an indication in a human that your internal conditions are stable, they're not changing? Can you think of something that's basically for you that's always, always, always the same? Any responses, Drew?
Not seeing any so far.
Okay, well, we'll throw out this very simple one. In fact, we'll throw out a number, 98.6. That's your body temperature. That is a very steady and consistent number. In fact, when it's not consistent, that's when things are in trouble. Obviously, if you have a fever, you may be sick. Or if you've been outside exposed to cold or maybe in some cold water, you can have a temperature that drops below that. We call that hypothermia. So the idea here is that your body, through various processes, keeps things at a steady, stable condition. And that's true for other plants and animals, although they have different ways of dealing with it. For example, there are some animals that instead of keeping their temperature steady, they find places where the temperature is steady. So cold-blooded animals, for example, so that might be like reptiles, where they have to adjust where they are in order to keep conditions within a reasonable range. All right, so the other part is exactly what is life? Could you recognize it if it were out there? I was trying to figure out a way to do this on our slides, and I really don't have a good way to reveal this one by one. So let's just kind of discuss, first of all, the idea, think about things that are living. You can use, yourself or animals in general. I mean, animals in general move and they reproduce. They gradually evolve over time. So there are things like that that we start looking for in terms of recognizing life. But then you've got plants. Plants obviously don't move around, and yet they still have some things that are in common with us. In particular, all living things, we mentioned before, they need food, so they have some way of processing or changing energy. So that's another key thing that we look for. So scientists have broken this down into a list, and in some ways, this is kind of a boring, dull list, I've got to admit, but it is a way to identify if something is truly alive. So one of the things that all living things share is they are some kind of structure, generally complex. Even the most simple of life forms have some fairly complex systems within them. So, but it's organized. It's not some just random scattershot type of thing. there's definitely a pattern that can be found in all living things. As we just talked about, all living things have to consume energy. They need some kind of food source. It can be widely varied, but all living things take in energy. That helps them to process nutrients. It also helps them to do some of the other things they do, for example, move around. So all things have to somehow control their internal environment. Like I said before, all things need some kind of stable, sort of situation. Whether warm-blooded animals, for example, help to regulate their internal conditions, or for outside things, plants, for example. Think of a maple tree. Obviously, the maple tree gets hot and cold depending on the time of year, but it is dealing with that in different ways. That's why maple trees don't have any leaves during the winter. They wouldn't be able to sustain those, and so it has a way of balancing things out. It gets rid of those leaves so it doesn't have to maintain them in the winter, and then renews them, obviously, as we get into spring. One of the things that all living things do, certainly you and I do this, just think of when you take a jacket, or maybe you don't want a jacket, shorts, or a big, heavy, winter coat. You are trying to respond to whatever's going on. And that's true, again, with all plants and animals. All living things make more living things. That's another key thing about it, is that's one of the key elements for any living thing. You've got to have more of you. And so plants, of course, put out seeds, and some plants reproduce by their roots, for example. Mammals, they have live young. So there are lots of different ways of doing that, but all living things make more of themselves. And all things grow. Now, it's not that they just continually grow, although some things do continually grow. Plants, for example, in general, will continue to grow. There are some plants that reach a certain point and they slow down. Humans, we certainly slow down at some point, but there are, some kind of growth that's going on throughout something's lifetime. And then finally, things change over longer periods of time. One of the examples I always think of in terms of things changing would be humans changing over longer periods of time. I remember I went down to Mystic Seaport down in Connecticut, and one of the things that struck me was they have a number of houses that were from the original seaport or that period of time, so the late 1600s and early 1700s. At that time, people were shorter. I was walking through doorways, and I'm not very tall, but I had to duck going through the doors because simply people on the average have been getting taller, not over thousands or millions of years. People have been getting taller just in the past couple hundred years. So the average height of humans has been increasing. So that's just an example of things evolving over a period of time that maybe we can relate to. All right, so thinking about life, life on the Earth, you can't miss it. It's all over the place. And there are millions of different species, and they come in just about every imaginable variety. So in some ways, it's just kind of really too easy to talk about life on the Earth. And yet it's the only place that we know absolutely for certain that there's life. Now, on the other hand, there are some pretty extreme environments on the Earth, very hot or very cold locations. And we do know there are life forms there. They're called extremophiles, simply because they live in these extreme conditions. So why would we be interested in that as opposed to, sort of our typical animals and plants that are around here? The more extreme, the more possibilities there are for life outside the Earth. And after all, that's what we're talking about today. We're talking about extraterrestrials, but in order to understand them, we have to use the terrestrials. We have to use the life forms that we know about. So we're going to go to Antarctica. Antarctica, we sometimes refer to it as the bottom of the world, although there really is no top or bottom. It's just how most globes are displayed. But there it is, Antarctica, an enormous continent, basically covered with ice. The middle of the continent, the ice in some places is up to 2 miles thick. There are no plants on this continent, and there really aren't any living things on the interior of the continent. There are some living things, but they're all around the edge. So it's some ways kind of a desert wasteland, and yet there are some things that survive there. So this is one, it's not in the interior, but it's toward the outside. There are these tiny little bacteria that create this reddish sort of output coming across part of a glacier. It's called blood falls, and that's because of the coloring. It turns out that underneath the glacier, there is a water source. And in that water source, now it's covered with a glacier, so there's no sunlight. There's no oxygen either, but there is something that these tiny microbes can use for energy. Again, all things require energy. This is actually found, it can create energy out of using iron. And so this bacteria basically it digests iron, turns it into energy, and that is part of its life cycle. Now, what happens is the glacier crosses the body of water. It actually picks up some of these bacteria and it comes out through the edge of the glacier. And that's what we see, this reddish deposit that they call blood falls. There is another creature that lives again on the outer edges of Antarctica. It's a tiny little shrimp object. And well, you can see in this image here, so imagine that is really only 1/8 of an inch. So it's a very tiny, tiny creature. But again, it lives in Antarctica. So here are a couple examples of some life forms that live in some extremely cold conditions. Just to give you a sense of how cold it is, in Antarctica at the South Pole, the record high temperature, the hottest it's ever been at the South Pole, is 5 degrees. So it is extremely cold. Many times the winter temperatures drop down below 100 below zero. So this extreme cold, obviously, not something that a lot of living things can stand, but a few of them have figured out a way to survive. The other place, and of course, this is where we think a lot of life forms had their origins, is the ocean. The ocean covers 3/4 of the globe. But in the interior, or really at the bottom of the ocean, there are some fascinating creatures living in some pretty extreme conditions. Now, if you're looking at this image, you probably can imagine, you can see the water there in front. This is a volcano that's just barely under the ocean. It's erupting. It's how islands in the middle of the ocean are formed. Hawaii is probably the best known example of that, but there are other volcanic islands that are scattered around the ocean. And so a volcano, we're talking about lava. Temperatures are thousands and thousands of degrees. So let's go under the ocean to a volcanic vent. You can see the glowing red here. This volcanic vent, the water temperatures outside it are over 800 degrees Fahrenheit. That's way above boiling. 800 degrees is hotter than the oven in your kitchen. So in this extreme environment, the temperature of the water way above boiling, you wouldn't expect anything could possibly survive. And yet, next to what they call these black smokers, and you can see why they're called black smokers, there is, of course, the volcanic vents issuing all kinds of things along with the liquid rock, with gases and so forth. But if you look on the lower part of the picture, you can see some sort of strange, it almost looks a little bit like lichens or moss. It's kind of pink and white. That is actually an animal, classified as an animal, but it lives next to these volcanic vents under these extreme conditions. So we now find something that can live next to a volcano and underwater. So those are two pretty extreme examples of life forms on the Earth. Now, a lot of life forms on the Earth are very tiny. Microbes and so forth make up the majority of life forms actually on the Earth. And these little tiny microbes, including bacteria, have had an interesting history. In fact, they are really the first kind of life form on the Earth. Now, some of the very earliest life forms, these tiny little green blobs, and you can see they're kind of all enclosed. You're really looking at something that you probably are familiar with if you leave a container of water out in sunlight for an extended period of time. It kind of gets green and slimy. Yep, it's algae. Algae is a very simple life form. And yet, from algae over thousands and millions of years, some of those algae cells decided to get together. And as they did, they gradually developed a process where they had an outside that kind of protected all the little cells on the inside. So you have these little green cells on the inside covered up with a nice little kind of covering or coating on the outside. Does that remind you of anything? Something that's green and it's got a coating on it? Well, think of plants. Think of leaves or needles on some of the pine trees. So if you get that idea, that's essentially one of the processes here on the Earth that life developed from some fairly simple forms and gradually became more and more complex. Now, again, I'm going to remind you of these four things, that all living things have these requirements. They need water, they need an environment in which they can survive, they need some kind of energy source, essentially food, and they need to have a fairly stable situation. It can't be wildly changing from one condition to another. So I do want to go back over these ideas with just a little bit of detail, in particular, water. One of the things that we've been doing in terms of exploring the nearby solar system is that if we are going to find life outside the Earth, one of the key things that we are looking for is water. If we can find water, there's at least the possibility of life. So why water? What would water's role be? Now, I'll give you a chance. Maybe if you have a chance, maybe you can type in an idea or an answer. Why would water be necessary for living things? You can think about yourself. Why do you need water? What goes on with water with you? Think of other living things. Can you think of a living thing that doesn't seem to need water? Here's a curious question. So if you're thinking about water, what does water do? What property of water? And it's actually, in some ways, kind of a surprising thing that water does. And so if you've been thinking about that, water dissolves everything. Now, that seems like a pretty amazing, think about boats and so forth. Hopefully, the boats don't get dissolved by water. Well, you have to think about time, too. Everything, truly everything, will eventually become dissolved by water. Sometimes it takes longer than others, but even things like plastic, where you don't think of plastic as dissolving in water, over time, over long periods of time, even plastic can become dissolved. So that is actually the key thing for water. Water dissolves things. Now, in terms of its role with living things, as water dissolves things, it makes it much, much easier for material to move around. So when you drink water, we talk about staying hydrated. Well, that's fine. But really, the water that goes into you is busy doing two things. It helps dissolve some of the nutrients that you've taken in, your food. As it dissolves those nutrients, it goes into your bloodstream and then to all the different living cells on your body. The other thing that all living cells do is that once they use something, and nutrients and so forth, to help keep themselves going, then you have some leftovers, some waste products. Water does this as well. Water dissolves the waste products and sends them back out again. You know that your waste products involve some kind of water, so think about that. But that's the key role for water. Water dissolves things, both nutrients going in and waste products going out. And that's true for all living species. Now, the other things, we talked a little bit about living space, a place that has the right environment. There are obviously lots of different conditions. That's why I use the extremophiles as an example of that. In extreme cold or even in volcanic regions, there are things that manage to survive. We talked about different food sources. Again, this is a wide range of things that different living things can take in terms of creating energy for themselves. And this, of course, the last one, having some sort of stable conditions of some sort. Now, I wanted to mention those again and go into a little bit of detail because if we're talking about extraterrestrials, we're talking about finding something beyond the Earth. And really, that's limited at this point to our solar system. There are explorations now where we're at least looking at visually different planets going around different stars known as exoplanets. We're trying to find planets that might be in a place where water would be possible. Obviously, too cold and it would be completely frozen all the time. Too hot and it may not exist at all. So scientists are looking for planets that would be close enough to a star to be warm, but not too close. And so that's part of what scientists are thinking about. But in order to find some life form besides here on the Earth, these are the places that we can physically get to. So it is our solar system. Now, these are the four interior or terrestrial planets, as they're known. On the left is Mercury. Next to the Earth is Venus. You can tell the Earth, obviously, and then Mars on the right. Now, surprisingly, all four of these have water, but there are some great limitations. The Earth is the only place that has an extensive amount of water. The water on Mercury, well, Mercury's a hot planet. You think you could find water where the temperature is 800 degrees above zero, where the sun is shining? Probably not. But it turns out that the craters on Mercury near the North and South Pole are so deep, and because the sun angle is so low, those craters, and you can see one on the right here, they're so deep that no sunlight ever gets there. Because the sun is the source of heating, that means that there is no heating that gets to the bottom of those craters. And so there's actually ice in some of the craters on the polar regions of Mercury. And if there's ice, that means there's water. We know from Antarctica, there is something that's living in the ice there. It has no air, no oxygen, no sunlight, and yet it survives. So could there be a life form here? It's at least a possibility. I just read an article about Venus. Now, Venus is also hot, in fact, a little bit hotter than Mercury. Its carbon dioxide atmosphere and its very high temperatures basically eliminate any liquid water on the surface. But I just saw an article that suggests there could be these tiny little droplets of water in its atmosphere. And if that's the case, maybe there's some sort of life form there. The temperature on the surface is 800 degrees Kelvin, which basically translates to about 860 degrees Fahrenheit. It's got sulfuric acid clouds. It really isn't a place that would be the most logical or likely place for life to form. This is actually an image from the surface of Venus taken by a Soviet or Russian spacecraft almost 30 years ago. They did not find any life forms there. The temperature's obviously very extreme. We'll skip the Earth because obviously we know there's life there, but this is Mars. So what do you notice about this image? You can see Mars. This is an image taken by the Hubble Space Telescope, I believe several years ago now. But look at the bottom of the picture. You see that lighter colored, kind of pinkish white region? Yes, that's ice. Mars does have water. Now, the conditions on Mars are certainly not as pleasant as the Earth. It's much colder. It's much drier. The atmosphere doesn't have any oxygen. Of course, our oxygen is supplied by the green plants that are on the Earth. But at the same time, there are some suggestions that Mars indeed may have life right now. We haven't actually got any astronauts there to do a serious amount of sampling, but we know there is water ice there. This is the North Polar region of Mars. It's been explored extensively now by several rovers. This is gathering up information, but at this point, nothing very specific about life forms there. And maybe there were life forms, but not now. So one of the things they're noticing, you can see in this image, the rock has layers. The reason that's important, those layers actually came from an ocean that existed millions of years ago. As the water slowly evaporated, the shoreline got lower and lower and lower. So you can see the lines, so to say, on these rocks. But the other thing that isn't visible, but they've been able to detect with the spacecraft, the rovers that are unmanned, they can find salt there. Why is salt important? Salt indicates evaporating water. As it turns out, if there was evaporation, there was a water cycle. And water cycle indicates a fair amount of water. And so at one point, Mars was much wetter than it is now. Again, one of the key requirements in terms of life. So there are additional spacecraft that have been investigating Mars. This is the Phoenix spacecraft, which landed near the polar region. It did dig down into the soil there. And if you look on the right-hand side, on the lower right, you can see just a little tiny patch of white in that orangish soil. That patch of white is ice that's underneath the surface. So that just indicates that we can see some ice, but there is even more ice underneath. And that, again, is a reservoir, a resource of some water. You can see there's the ice in the image. On the left, it was about 20 days old, and then 24 days old on the right. You can see it's decreasing in terms of how much ice you can see. So it eventually goes into Mars's atmosphere. This is an image that got a lot of attention, and I forgot once again to plug in my computer. Hang on, my computer's telling me that it's running out of juice, so that's easy to fix. Hang on 2 seconds. So anyway, as I'm doing that, and you can look at, let me just get rid of that. You can see it kind of looks like some kind of creature in there. Well, it turns out we don't know what that is, but that came from an asteroid or a meteorite that came directly from Mars. Now, in terms of what that is, we're not sure. And if we could find more of these, that would be really helpful in terms of understanding, are we finding some kind of fossilized life form from Mars? It is possible. So scientists continue to explore that idea. So we go out beyond Mars, out beyond the terrestrial planets, we get to what we know as the gas giants. So actually, before that, we'll go through the asteroid belt, but only briefly. There are no signs of any life there. So there is the asteroid, or going beyond the asteroid belt, the giant planets, Jupiter, Saturn, Uranus, and Neptune. You can see the Earth kind of in the middle of that, just to give you an idea of how large these planets are. Now, these planets have no solid surface. Again, one of the requirements of life is to have a place to live. Without a solid surface, it's highly unlikely there will be life forms in their atmospheres. But every one of those planets has an extensive number of moons. And so it's the moons of these planets that the scientists have been focused on to try to figure out, are there life forms there? These are the 4 large moons of Jupiter: Io, Europa, Ganymede, and Callisto. Now, Io on the left is a volcanic moon. It doesn't have any water. And so we can pretty much eliminate that in terms of a likely location for any kind of life form. But Europa, also relatively small, actually has an extensive ocean underneath an icy covering. It is also possible there is an ocean underneath the ice of both Ganymede and Callisto. We're not as sure about that. But there's an image of this volcanic moon, Io. Again, not really any thought of seeing any life forms there. It's very interesting. It's got volcanoes that are active, but no life forms. Now, Europa, on the other hand, has this huge ocean. In fact, it is now estimated that Europa's ocean may be more extensive than the Earth's. It has more water than the Earth. If that's the case, this is a place that suddenly gets a lot of attention. Now, there is a thick ice coating on the outside of it. It is cold out here. Temperatures are in the range of 160 below zero. And so there is a thick coating of ice. It may be 40 to 100 miles thick, but underneath that is a very deep and extensive ocean. How does it stay liquid? Well, one possibility is that it stays liquid because there are volcanic vents, just like on the Earth. So, just thinking back to what we saw on the Earth, those extremophiles, those creatures that live next to volcanic vents, that is certainly a possibility on Europa, but it's under 40 miles of ice. Will we ever find out? Well, we're actually going to have to be pretty careful about that. One of the concerns about going to another planet is extraterrestrials. In this particular case, it would be us. We would be the extraterrestrials, the outside influence. We wouldn't want to bring any microbes to Europa. So scientists are still working on ways to guarantee that. They have discovered that even spacecraft that have been out in the midst of space, occasionally some microbes, some bacteria can survive the conditions of space. So we have to be pretty careful about that. But it is possible that underneath that thick blanket of ice, there could be some life forms in that ocean. If we go out to Saturn, again, Saturn as a gas giant does not have the likelihood of any life form, but it has a number of moons. And its most likely candidate might be Titan. Titan's the only moon in the solar system with an atmosphere. And it looks like in this image that you can see some, what almost looks like Earth. You got these brown spots like land and some bluish areas for water. There are areas of liquid lakes there, but it is not liquid that you can deal with. First of all, the temperature is 290 below zero. And secondly, the liquid is not water. It turns out that the lakes of Titan are made out of mostly methane and ethane. These are gases on the Earth. When the temperature gets that cold, though, 290 below zero, it turns into both liquid and ice. And so there are actually a methane cycle taking place on this moon. So maybe some life form had figured out, methane could dissolve some materials. Maybe some life form has figured out how to use that to survive. They've also more recently detected there is a layer of water underneath that. Another possibility. Now, there is one other moon that scientists are curious about at Saturn, and it's known as Enceladus. Enceladus has these funny little cracks on parts of its surface. And in those cracks, and this is an image taken by the Cassini spacecraft, you can see little jets coming out from the surface of the moon. That's water. Inside the moon, there's actually liquid water that's coming out. And of course, with the temperatures there near 300 below zero, the water turns immediately into ice. So you get what you might call ice geysers. The key thing here, there is liquid water. It's underneath the surface, but where there is liquid water, there's at least the potential for some sort of life form. Now, if we get out beyond that, both Uranus and Neptune also have these icy moons. We have been surprised how much water there is in our solar system, even if we go all the way out to Pluto. We now know that there is ice. In fact, Pluto is made out of, in part, water ice, but the temperature is 400 below zero. Life forms there, not very likely. And finally, if we go far enough out, we get out to the realm of comets. Comets are described as dirty snowballs. They are primarily made of ice. Some of it is water ice, but there are other ices as well. Frozen carbon dioxide, frozen methane, frozen ammonia, to name some of them. And as they get closer to the sun, they actually are in orbit around the sun, just in a very different orbit than the planets. They have these very narrow, very sharp orbits that come in very close to the sun and then go way out far away from the sun. As they get close to the sun vaporizes the ice. That's why you can see all of that, what we call the tail of the comet. The ice becomes vaporized and the gas goes behind it, and it also releases tiny little fragments of rock. We have found, though, and this is some recent discoveries by a couple of spacecraft that have landed on some comets, they've actually found that there are some of these complex molecules that could eventually turn into some kind of life form. There is one possibility, a theory that somebody has proposed, that comets crashing into the Earth in the very, very first stages of the Earth's existence 4.5 billion years ago could have brought these molecules, which would in turn perhaps give the building blocks for life on the Earth. So here's another possibility in terms of where life forms might originate. So we've discussed a lot of possibilities in terms of, what life forms are, what they need, and where else we might be able to find that. The idea, again, one of the key elements as far as we know, water, although perhaps something like the moon of Saturn, Titan, where there is liquid, it's just not water. Maybe there's a life form that's figured out how to use that in the same role of water, able to dissolve some materials, both bringing in nutrients and taking out waste products. It's a complex subject, but it's one of those things that we know that beyond the solar system, we are looking for other planets with similar conditions to the Earth so that liquid water would be possible, and therefore life forms would be possible as well. So that's some thoughts about extraterrestrials at this point. If you have any questions, you're certainly welcome to throw them into the chat window, or you can email us. And we'll try to get back to you about those. But hopefully, and also, if there are any extraterrestrials out there watching, you can kind of send us a note as well. Always good to hear from our neighbors. Maybe we have a few things wrong, you can correct us. All right. Well, thanks this morning for joining us, and we'll see you again soon.
Yeah, and just a warm thanks to Mark Breen for teaching our class this morning, and a thanks to everybody who joined us either on YouTube live stream, on our Kingdom Access Television, or your local cable affiliate, or who's in our Zoom meeting today right now. We're excited to have you with us, and of course, keep checking fairbanksmuseum.org for all of the museum's wonderful online offerings. I hope everybody has a wonderful rest of your day.